Hey everyone, you are watching Surreal Cosmos. If you like our content, make sure to hit that subscribe button with the bell set to all notifications. Let's dive in. Asteroids have more than enough gold, plus other metals, to provide a few lifetimes worth of fortunes. But there are plenty of other reasons asteroids are valuable. The majority of the metals we use on a daily basis are buried deep within the Earth. Almost all of the heavy metals sunk to the core of our planet when it was still molten, which is difficult to reach. Later asteroid strikes on Earth's surface provided the accessible veins of gold, zinc, platinum, and other important metals. Those asteroids are the broken remains of nearly planets, but they have the same elemental compositions as their larger planetary cousins. You don't even have to go into their cores to find it. The asteroid 16 Psyche, for example, contains roughly 22 billion pounds, 10 billion kilograms, of nickel and iron, which are used in everything from reinforced concrete to mobile phones. If we maintained our current consumption of nickel and iron, 16 Psyche alone could supply our industrial needs for several million years. The biggest issue with asteroids, though, is that they are so far away. Not only in terms of space, but also in terms of speed. A rocket must alter its velocity from 0 to 5 miles per second to launch from Earth's surface and into orbit, 8 kilometers per second. The rocket must vary its velocity by 3.4 miles per second, 5.5 kilometers per second, to meet an average asteroid. That would require almost as much fuel as the launch itself, which the rocket would simply have to carry as dead weight, adding to the already exorbitant cost of attempting to set up a remote mining operation. So, rather than attempting to harvest a faraway asteroid, how about bringing the asteroid back to Earth? The ill-fated Asteroid Redirect Mission, ARM, by NASA attempted to do exactly that. The mission's purpose was to collect a 13-foot, 4-meter, rock from a nearby asteroid and return it to cislunar space, the area between Earth's and Moon's orbits, where we could study it at our leisure. Unfortunately, NASA canceled ARM in 2017. Some of the crucial technologies were used in other projects, such as NASA's OSIRIS-REx mission to the asteroid Bennu, and ion engines are still being researched and used. When properly scaled up, a future version of ARM could potentially send large chunks of asteroids, if not entire small asteroids, into nearby outer space. In fact, a recent research discovered a dozen possible asteroids with diameters ranging from 6.6 to 66 feet, 2 to 20 meters, that might be propelled into near-Earth orbit with a velocity shift of less than 1,640 feet per second, 500 meters per second. And, while it would take some time, the solar electric propulsion concepts devised for ARM would be fully capable of doing so. Many of the problems of asteroid mining are greatly lessened once an asteroid reaches near-Earth orbit. Just think about how much easier it is to go to low Earth orbit, or even the Moon, than it is to get to Mars. The red planet's extreme distance from Earth presents enormous logistical, engineering and technical challenges that we are still trying to solve, all while we've maintained a continuous human presence in low Earth orbit for over 2 decades. It would be much easier to research and test alternative mining tactics on a cislunar asteroid. Furthermore, bringing its resources back to Earth would be much easier. Any asteroid redirect mission intended for mining would instantly become an asteroid redirect mission for rescuing Earth. If we can successfully shift the speed and orbit of a harmless asteroid, we can theoretically do the same for a deadly Earth-crossing asteroid. For example, the solar electric propulsion engine could be humanity's best hope of avoiding disaster. Regrettably, the project was cancelled. That's all for now. By the way, share this video with anyone whom you think might like it. See you in the next video.